Welcome to Custodian. Beam shaping is being a significant trend in laser industrial applications for solving both process quality and robustness. In this sense, Custodian is developing a complete methodology that covers all the steps needed in order to define the optimal beam shape to adapt it to every customer needs. Custodian is then providing a totally disruptive and dynamic solution, totally compatible with any high-power continuous wave laser system and cheaper than the existing ones. Custodian is based on MPLC technology, multiplane light conversion, that has been developed and patented by our partner CAILABS.
I work in the innovation department of Marelli Green Technology System. What I have got here is an example of a rear muffler of an automotive exhaust system that can be welded with laser welding. These two half shells are stamped, and when you couple them, you can see that the gap between the two subcomponents is not constant, is variable. This represents an issue for the laser welding and requires complex tools to press together the two parts in order to minimize the gaps. Of course, this implies higher cost for the process and lower process speed. Moreover, what can happen if the tool is not pressed sufficiently is that the welding is not complete. As you can see here in this example, possible issues is the lack of complete penetration of the laser welding. This is something that can happen if the two tools do not compress the two parts to be welded in a good way. Custodian technology, on the other hand, gives the possibility to laser weld the two components without the use of any tools, because the technology of Custodian is able to manage variable gaps from 0 to 0.4 millimeters. This, of course, has great advantages in terms of process cost. We save the money for the tools, and of course also of process speed. With Custodian technology, the welding of a single part can be much faster.
The methodology for beam customization lies first on the determination of the thermal cycle able to reduce the defects generation during laser beam welding, studying both the process and the material. Second is multiphysics simulation and beam modeling combined to determine the beam shape able to produce this thermal cycle. And third, the multiplane light conversion technology to implement a device to produce this beam shape. In parallel, a closed-loop process control is developed to adjust this beam shape in real time.
See a simulation of a laser welding process on two steel sheets with a gap. The presence of such a gap can lead to defects like porosity, underfill, and lack of penetration, just to name a few. The simulation helps to visualize and understand fundamental physical processes. With this knowledge, further process optimization is easier to undertake, and the parameter space of novel beam shapes can be narrowed down in simulation prior to the fabrication of the MPLC system.
I'm product line manager at CAILABS in charge of laser material processing applications. Within the Custodian project, we are in charge of designing and manufacturing the beam shaping modules. These modules will provide the optimal beam shape, which has been calculated by our partner from TU Vienna. Once the material sees the optimal energy profile, the process will be improved, can be laser beam welding of stainless steel, or can be selective laser melting of nickel-based superalloys. This beam shaper is based on our patented technology, multiplane light conversion.
During the last decade, the industry has adopted laser radiation as an excellent tool for many of their applications. The nature of industrial processes based on lasers demands to integrate in the production line sophisticated systems for real-time monitoring and, if possible and required, controlling specific parameters. NIT designs, manufactures and commercializes infrared sensor cameras and systems based on them. Here you can find a 8-inch silicon CMOS wafer with focal plane array sensitive to the infrared radiation manufactured by NIT. These sensors are the heart of our high-speed cameras and imagers. Custodian project requires NIT expertise in developing monitoring solutions for helping to the consortium to reach all project objectives. In the frame of Custodian project, NIT has developed innovative sensors for monitoring and controlling in real time two of the most used industrial laser-based processes, laser beam welding and powder bed fusion. The objectives of Custodian project are ambitious, and their consecution have required to face important technological challenges. The energy distribution of laser radiation, the shape of the beam, is modified according to specific requirements for obtaining reliable and optimum results. Beam shape modulation has direct impact on melt pool geometry and dynamics. The infrared sensor adopted by NIT in the frame of Custodian can capture the image of the melt pool at frame rates as high as 1 kHz. Here you can find one of the units developed by NIT in the project. It is designed for being coupled to the laser head for working in coaxial mode. A powerful electronic inside the unit is capable to process in real time all melt pool images acquired and extract useful information on the process itself, supplying output signal for controlling key process parameters.